Welcome to the Bytecode, where we look at smart contracts with the people who wrote them. I'm your host, Shafu, and today's episode is with Eloi from Openfort. Eloi, thanks for taking the time, dude.
Hello, thank you for having me.
Yeah,
Nice.
for sure, for sure. So, yeah, Eloi, why don't you briefly introduce yourself, introduce what Openfort is, and then show us the smart contracts?
Okay. My name is Eloi. I'm from Barcelona, and I've been working in cybersecurity for like all my career. And lately, I've started as a founding engineer at Openfort in order to we are a company that tries to provide frictionless crypto accounts for players, so for games. So instead of having all those annoying pop-ups while you're playing a Web3 game, we are providing a solution which users still have accounts. They can still have the full ownership of their assets, but they will not have that annoying experience of all pop-ups and all those tedious experiences that you may be familiar with if you are into Web3 gaming.
Nice. Okay, cool. Yeah, I think you wanted to start by going through the 4337 because you're using that a lot, right?
Yes, exactly. So the key reason of why we are able to not be constantly presenting users with pop-ups is because we are leveraging account abstraction. If you're not familiar with it, account abstraction is a term just to if let's say you're from if you're familiar with how Ethereum accounts work. Normally, you would be using an EOA, which is an externally owned account, and those accounts are just they have like a private key and a public key. So the public key is used to represent your account address, where you can give to anyone in order to receive funds. But then all these funds are controlled by this single private key. So the person that have the private key is able to do anything with the account. And if you lose the key, you cannot do anything. So it's like black and white or one or zero. So you can either do anything with that externally owned account, or you can do anything if you lose the account or if you don't have the private key. So with account abstraction, this changes. So instead of having this Boolean thing of access or not, now we are using smart contracts for to act as accounts. So then you can code any rules that come to your mind. So let me show you the EAP that lets you do that, as well as some cool articles from Alchemy that will help you understand how it works. So the EAP or ERC is the 4337, and it's defining a way to use account abstraction, which is not a new term, but using an alternative mempool, which is that instead of using the typical mempool that you would have when you interact with any EVM chain, now it's presenting or it's proposing an alternative way to group together a lot of transactions, which are not actually called transactions. We will see that now, and then put them on chain for you. So that now you don't really need to have, for example, gas, or you don't really need to have the private key. As long as you comply with certain rules, you'll be able to put things on chain. Let's put it that way. So, before talking about the specifics, let's see that there are a lot of others here. One of them is Vitalik. The rest are part of a group called ETH Infinitism, which is the GitHub repository that we have been using for the basic implementation. So in general, the idea is that, as I said, we don't have regular transactions in account abstraction. We have what we call user operations. So in order to avoid confusion, they changed the naming. So now what you send what you send to Ethereum or to the EVM chain is not a regular transaction if you don't have the private key. When you use account abstraction, what you send is user operations. A user operation is kind of a transaction. Let's see how it is defined. But a user operation has some similar fields like you would have on a regular transaction, such as the sender, a nonce, or some gas information as well as a signature, but it has other elements, other fields, which tells the component of the account abstraction network that you want to perform a certain transaction. So I think this EIP is quite famous right now, but it's also famous because of its like density or its difficulty. It's quite a long EIP where you have all the different technical details as well as diagrams and everything. So I think we don't have enough, like we don't have time to cover this in detail because we will be mainly talking about Openfort, but I really invite you to like take a look at it. And if you want like more like a high level overview of what is account abstraction, as I said, I recommend you the Alchemy documentation, where with all the different information about it, as well as their one of their websites. Like here, they have a post, like a blog post, consisting of different parts. Like they have like 4 parts called like you could have invented account abstraction, and instead of just explaining you how it really works, it's like a walkthrough of how you could like how they invented it, like how it works the way it works, right? So I think I had here another tab about like yeah, here. Um, Here on Alchemy's website, you can also see like a more like everything working with diagrams, and I think it's one of the best ways to see like in a like see it in not in high detail. But for example, here they explain what I said before, that like normally an account on Ethereum is like an externally owned account, but then with account abstraction you can have a smart contract acting as an account, right? So with externally owned accounts, you have your public key tied to a private key where you can do like you can do anything with that account as long as you have the private key. But then with the smart contract accounts, the possibilities are endless. So you could define any authorization scheme or authentication scheme. You could define, like for example, gas policies, which is something that we do at Openfort. The possibilities are endless. So this is thanks to ERC 4337, as we said, and account abstract like user operations are like you could think of them as the transactions for the ERC 4337, and here in their diagram they lie at the beginning, because user operations is the thing that we send as Openfort as a product. We have an API that sends user operations to the bundlers, which is the other element that I need to introduce right now. Bundlers are like miners or like validators. They are an element, like a network element that they are mainly in charge of getting user operations from our users or our players and sending them on chain. So a bundler is mainly like getting a lot of user operations and then checking whether they are correct or not. You may be familiar with this kind of behavior if you know how transactions work on any EVM chain. And then they send all these user operation in. Now they go on chain, and they like, thanks to the bundler, they go on chain. So you may think here, okay, but what is this bundler getting from this job, right? I mean, as a bundler, why would you put something that is not a native transaction on chain? And it is because one of the things that the bundler check is whether they will be repaid or not, right? So they can be repaid by either the smart contract account. If the account have some funds, they could in the verification code, they could say, okay, at the end I will pay you. Or you could say, I have a paymaster. So I have someone that will sponsor my user operation. So when you put that transaction on chain, don't worry, you will be paid back, but not by my account, but the paymaster. This enables us to interact with Ethereum accounts that do not have funds yet. So this is not magic. This is thanks to the fact that the bundler is also interacting with another element that we have to introduce, which is the entry point. The entry point is the element is a smart contract, which is what we call a singleton. Singleton meaning that there's only one. So we have this entry point smart contract on like most of the EVM chains that will accept transactions coming from bundlers. Those bundlers will say, hey, I have like this 10, for example, user operations that I want to send on chain using a regular Ethereum transaction. Please see whether this will be accepted or not by this standard. So what the entry point does is mainly two things. First, it verifies whether the user op is valid or not. If not, it will be rejected and let the bundler know. And then when it checked that it will be paid back and everything works as expected, it will be the one actually calling the smart contract account. So here, from the beginning until this point, this is not anything that Openfort has developed. This is something that has been developed and proposed by these guys of the EAP 4337. And you can find the code about all the related code here. So for example, if you go to the account abstraction repository, you can go to contracts, and I think it's part of the core and you have the entry point. Right now, the current version of the entry point is 0.6.0, and here you have the singleton contract, where the only only thing that it does is verify whether a user operation is valid or not. And then if it's valid, it makes sure that the execution works correctly and the fees are paid as expected. So you can find this entry point deployed on most EVM chains. For example, let me see, for example, on Snowflake that I have here open for the example. I'll show you later the address where this is deployed. So you'll see that in all EVM chains they use the same address. Okay, so let me briefly finish with the explanation of how ERC 4337 works, and then I'll walk you through our code. So as I was saying, all these elements are independent of how Openfort works. So in all EVMs, you have an account, which can be an externally owned account or a smart contract account. Thanks to the 4337, you have the following elements. So we have this meta, which you could call it meta transactions, but the name is taken. So this kind of transactions that act as that are called user operations that go through the bundler and are validated by the entry point, right? Then you could also have an element which is optional, which is the aggregator that aggregates a lot of transactions with different signatures. And I would say that the final element to understand the 4337 is the paymasters. Paymasters are not singleton, even though here they're not in plural. You can have many kind of paymasters. So a paymaster in the end is just a smart contract that decides whether or not they want to sponsor a user operation, right? So they could sponsor it maybe because you're paying them back in an ERC20, for example, or you're paying in stablecoin. So you could say, okay, I don't have Ether. I don't have native funds to pay for the transaction that the entry point and the bundler will put on chain, but I have a stablecoin, right? I have DAI, for example. So what you could do is say, okay, Paymaster, if you sign this for me, I will, by the end of the user of the transaction that you will let the entry point put on chain, I will pay you back with, I don't know, the amount, X amount of DAI. Or for example, you could have a paymaster that doesn't want Ether or DAI back. It's just sponsoring for free because you want to have a easy experience. Let's say you're a Web3 game that wants to have a lot of users, enroll a lot of new players. So you could say, okay, for this first month, what I'll do is I will sponsor all transactions for all accounts up to, I don't know, $100 worth of ETH. You could do that. So what you would have, instead of just having this typical barrier of entry that you have with all Web3 games, you'll have a lot of users that don't need to actually have native tokens, right? So the overall picture would be that you have user operations, which are sent using regular HTTP requests and responses that go to a bundler that then forwards all like the operations that users want to do to the entry point, and then interact with a smart contract account. The optional elements are the aggregator and the paymasters. And we actually are using, like currently we are using two different paymasters on Openfort, which you'll see. Finally, you also have this ERP or ERC that is still under development, which is they're right now proposing different like modular smart contract accounts, but this is out of scope right now. So once we've covered like more or less how the EIP that standard works, right? You have information here. Let me go to our specific contracts.
Yeah, Eloi, let's try to summarize for
Sure.
337 for a second. So
Yeah.
basically in gaming, the benefit is you want to abstract away the wallet stuff. You don't want to, I get a sword or something and MetaMask opens up and you have to confirm you need some ETH. You don't want that.
Exactly.
So Force 337 is great because you can do it without any consensus changes. All it needs is like a separate mempool, specific smart contract, and the benefits are you can bundle a lot of transactions. You can either pay in ETH or an ERC20, or a paymaster pays for you.
Exactly.
Okay.
Like you said it like perfect. I mean, yes, the idea is that instead of having those limitations that you always need to have a like a private key, for example, those like 12 or 24 words, and you to put things on chain, you also need gas, you have a lot of pop-ups. Instead of having all these, what you can do is you can have like a regular game that underneath it's like building all those user operations that put transactions on chain. In that way, you could, for example, I don't know, like still have like for the user, it would be like more like a Web2 game where they pay using credit cards and they don't even notice that things are going on chain. However, they do have an address where all the assets are being sent to. So then if the user says, hey, I want to, I don't know, sell this sword or this shield for I don't know, any other token or any other ERC20 or ERC721, they could still do that. Because like in reality, even though it depends on the game, some games will like choose to like show it to the user. Some of them will maybe choose not to show a lot of technical details to the user. But in the end, the idea is that they will still have the option to be the real owners of the assets without all the burden, right?
Awesome.
Good, thanks. So here in this URL, you have you have our GitHub repo where you can find different like ways to interact with Openfort. Samples is a really good way to like more like to have like a hands-on experience with Openfort where you can, for example, try it using your own external KMS, use Firebase, use Rainbow, so different samples on how to use Openfort. But today we're going to dive deeper into the contracts. So I have here my IDE with the contract code, and I don't like if like for example, let me show you like the main as always like we are using Foundry. So I like you may be familiar with it. It's like the framework developed by Paradigm that uses Rust. So it's like a very fast development suite. So we are using it. Then we have the contracts in the contracts folder, and we are mainly leveraging the infinitism contracts. So here in the lib folder, you'll find the account abstraction, which is actually like a submodule, and we are using all the contracts that they like the basic contracts from the ERC 4337. So for example, you see here the entry point or different interfaces for interacting with it. So here, like before looking at our accounts, you can see that there's something called base account, which is
Eloi,
yeah.
could you please zoom in a little bit more?
Sure. Let me see if I can do it. No? Yep, now. Whoop. Is it better or maybe a bit too much?
Nice, perfect, perfect.
Perfect. Okay, cool. So the guys that are working on the 4357 standard, they proposed like something called base account, which is the most basic contract that is compliant with the 4337, right? So what we do instead of trying to like reinvent the wheel and I don't know, like making something that would not be standardized, what we do is we inherit from base account, which is the main purpose of it. If you look at it, it's an abstract contract, so you cannot deploy a base account. What you need to do is inherit from base account, which inherits from the interface, and then like create your own account, right? So and like it's doing like the regular stuff, like declaring the Solidity version, importing some interfaces, and then, for example, an interesting part of like ERC 4337 is that the nonce of the account, regular like normally when with an EOA, with an externally owned account, you have the nonce that is being like controlled or like followed maybe by by your wallet. For example, let's say you have MetaMask, and every time you do a transaction, it is your wallet that is in charge of like updating the nonce, and typically you would go from one, like you would any transaction will update the nonce by one, right? So with ERC 4337, it is the entry point that updates the nonce. So remember, the entry point is that singleton contract that is which is means that there's only one. So for each account on using account abstraction, it will update its nonce. So in order to get the nonce of an account, you will have to query the entry point, which is getting the nonce of this address. The zero is just an index. Here, because the entry point, like because the way you retrieve the address of the entry point can change, even though it's a singleton and there's only one, the entry point can be updated. So they let the developers choose how you create this view function. So the idea is that it will return an entry like an interface of an entry point of a valid entry point, but they are not like setting this in stone. So you could change the behavior of this view function. Then one of the most important functions that any smart contract wallet compliant with ERC 4337, one of the most important functions that they need to have is the validate user op. This function is going to be called by the entry point, and it's going to perform the following actions. So here, instead of overriding this, what you could do is, for example, modify the way you validate signatures or validate funds or pay free funds, right? So this is one of the entry point of like the entry part of your account that will be called by the entry point, right? Then we have this like this big function is acting as a modifier instead of using the regular only owner modifier. What they did is, because it's a bit more efficient, what they did is they created this internal v function saying that okay, this specific function can only be called by the entry. So they're making sure of this by calling this internal function. Then they have a virtual function, which is not defined here. This is why, like, because this is an abstract contract, it's not defining it, and it's saying, okay, it's up to the developers, to the account developers, to choose how to validate signatures. And here is you'll see how Openfort does it, like how we do it. Then validate nonce and pay pre-fund. So there's nothing much here. So as I said, like this base account contract is an abstract contract that is like setting the basics, and then from this you could implement your own. So from that, what the guys at If Infinitism did is that they provided some samples. So this we are not currently using it on Openfort, but it's like if you're starting, you could like maybe take a look at the simple account, which is this time this is not an abstract function, abstract contract, sorry, because
Yeah.
it's yeah.
Eloi, could you maybe close your terminal so we can see a little bit more?
Sure.
Yep.
Yep.
Nice.
So this time, instead of having like an abstract contract, we have the most basic, like this is more like a proposal. They propose like a contract that would follow uh, like the basics of an ERC-4337 account, together with like more stuff, like maybe like it's upgradable and it can handle different tokens and everything. So here you see like we will see that too in like with our Openfort accounts, but here you'll see that they have an owner, they have a private variable to keep track of the entry point, which is immutable because, as we said, like normally we will not be updating the entry point, and if we do, in this particular case, they will need to deploy a new simple account because this is not changeable. As I said, like this is a pretty basic implementation of a valid account because the entry point is just identifying the entry point. The constructor is just setting the entry point. Here they have like an only owner, and a cool feature here is that they have like an execute function and an execute batch function. These two functions are the ones that our players will typically call. So we have it like implemented in our accounts too. So every time a user wants to perform a certain action, they will send a user up saying, please call this, like, please entry point, please call this execute function with this destination contract, with this amount of ether, calling this function encoded in bytes, right? Then they have a way to initialize the contracts, like a way to make sure that the call is coming from the owner or the entry point. So here the owner can call the simple account directly. So this means that any function that have like any function, like for example execute, that have this will be able to will be callable by either the entry point because it's following a user operation, or directly using a regular Ethereum transaction by the owner. So with this, you see that execute is callable by the owner using a regular transaction or by using a user operation. Here, it's saying like, how do I know that the signature is valid? Like when I receive a user up, I need to make sure as the entry point, because I'm like, this is, as I said, like this is will be called by the entry point as the user, as the entry point. I need a way to know whether you're allowed to do this or not, right? So when we use a regular transaction, we are fine. You're the message, like if the message sender is the owner, we're fine. But what if it's the entry point? The entry point will call this, and if they execute this, they will provide a user up that the user has sent together with a hash. The user up has a signature, right? So what we do, this is what they do here in this simple account is pretty basic. They're just recovering the address and say, if the person that signed this hash is the owner, return this hard-coded value, like this OK value. If not, just give an error, right? So this is like one of the most important functions. But in the end, here in this simple account is pretty basic, pretty simple, as the name says. We'll see how we implement it in Openfort now. Then we also have like the call function, a way to get the deposit. Well, you can deposit funds to the entry point to say, okay, I'm committed to this ERC-4337 standard, and I will pay the user ops by using this deposit, right?
Question, Eloi.
Sure.
I'm a little confused right now regarding the signatures.
Okay.
So how 4337, okay, I'm like an end user who plays the game, right? And I have a couple of transactions that I want to execute. Obviously, I don't have a private key, public key pair, right? So I bundle up those transactions. Those transactions go into the mempool.
Yeah.
Who's signing those transactions now for me?
Okay. That depends. Okay. So let's say so we have two cases here: the custodial and the non-custodial one. So if you're a self-custodial, like you have your own keys, you could either make a regular Ethereum transaction or sign the user operation yourself. So this is like the most Web3 native way. But then the option that you're asking is, okay, I'm a Web2 user. I don't know that this is happening. So underneath, what we are doing is we are generating a user operation that will be signed by the owner that we are making this custodial or the the Web3, like the game developer, they're making like they have the custody of such owners, right? So they will be the ones actually signing those transactions, right?
Mm.
So the user says, okay, I want to do this. I approve the creation of this user op, and then the game developer will be the one actually signing this. So if you notice, this is like a hybrid. It's not like I don't have like the full control as a user as of yet. Like while I'm using the custodial option, I'm not the one actually signing. This is because I don't have the pop-ups. But then it's the game developer sending these like signatures. But we'll see now that we have like a something that is middle ground, which is the session keys, yeah, which we'll see now. So well, this was a simple account to make sure we all understand. So let's see how we do it in Openfort, and you'll see that we have like a something in the middle. So if we go to our contracts, we have the different interfaces, box that we use for testing, paymasters, and core. So let's focus on core. We have right now we have like five different types of accounts. They all inherit from the base Openfort account. So the base Openfort account has like the main logic, and then we have different options. So you could either have an account that you can upgrade one by one. So each player can decide whether they want to upgrade to the next version or not. A static account, which is the most cheap account to deploy, which is not like it's not very used. Like it's like the most cheap to deploy, but it's just that static. You cannot even upgrade it. Then you have managed, which is a kind of account that when the game developer chooses, they can upgrade all accounts at once. So let's say you're using V1 for your accounts on that particular game. And then the game developer says that, okay, I want to make this new functionality. They can upgrade all at once. So this is like a very cool concept. Then we have EAP 6551. I don't know if you're familiar with this standard, but they are the token bound accounts, which means that the owner this time is not a regular externally owned account. The owner is the whoever has an NFT. So in this way, what I can do is I can have tradable accounts. So in Web3 gaming, we are seeing a lot of clients that say, hey, I want a user, like I want players that can after I don't know playing for several months, they can trade such accounts. So what they do is they can send the NFT to someone else, which is the owner of the account. So in practice, what you'd have is someone selling the account, right? So when you buy and sell the NFT that is the owner of the Openfort account, what you're effectively doing is selling and buying and selling Openfort accounts here. And finally, the last type of account that we developed is the recoverable accounts, which are making use of social recovery. I don't know if you're familiar with it, but there's this cool blog post by Vitalik, which explains how they work or they should work. And it's a type of account that you could, I don't know, you could, let's say, you lose your owner, your owner private key, and you want to recover it, you could ask different guardians that you have previously configured to start a recovery process. So let's say you have 5 guardians, like two members of your family, one member of your work, and then Openfort can be also a guardian. And then you can ask them off chain, please start the recovery process. Once they start the recovery process, they have to submit their signature saying that I want to recover this account. And then after some time, after like depending on the configuration, but typically 2 days, they will be able to change the owner. In case you find the private key before these 2 days, you can always stop the recovery process. I don't know. Let's say you're thinking that one of the guardians started the recovery process by mistake or because they are like now a malicious user, a malicious guardian. You can stop the recovery process and remove that guardian from your account to stop this process, right? So these are all different kinds of accounts that we support right now on Openfort. We have more accounts in development right now, but these are the ones that we are using right now. But the main logic is always in the basic Openfort account, right? So if we inspect this contract, we'll see that they're really similar to the simple account that we've seen, which also inherits from base account. As you'll see, it's also abstract. as the base account because the final implementation will be done by these four types of accounts. But the basics is that they are all initialable, they are all ownable, they are all they all support the EIP 712 for type signatures, also the EIP 1271, and they can all handle different tokens like ERC 777, ERC 721, or even ERC 1155. Something that a lot of our clients notice here is that we are not using the regular ownable type of accounts. We are using the ownable to step. And this is like an improved security measure. So when you want to transfer, for example, in the previous discussion that we had, no, like you asked, okay, who owns the account? So what we could do is, okay, at the beginning, the game developer or Openfort can have the custody, but then they can transfer, the user can request a transfer of the owner. And then once we do that, the Openfort or the game developer will start the transfer ownership process, but it will be the user that needs to actually accept this ownership. So in case they submitted like a wrong address or they don't really know how to use it, they will never be able to actually gain ownership. They must, in a way, prove that they have like the control of that account. So this is more like a extra security layer. So here we have one of the key elements of an Openfort account, which is session keys. Session keys are like a mapping between like they're mainly addresses that represent a session, right? So you have certain like validity in like you can have like users can register using our Openfort API. They can register a session key and say, okay, from now on, I don't want to, because I don't know, I have like self custody. I have the owner of my Web3 game account, and I have a lot of pop-ups all the time. So right now, what I want to do is I want to leverage this option that Openfort provides, which is session keys. And I will now register a session saying that from today until tomorrow, I can do like 100 calls without even like prompting, like without having these pop-ups, right? And I want this to be valid only for this specific game, right? So you sign this, you have a pop-up because you are the owner of this Web3 game account. But then from now on, from this, like, I don't know, from this 30 minutes or 1 day period, however you want to define it, you will not have a pop-up at all. Why is that? This is because if you go to how session keys work, you'll see that we validate, like we tell the entry point, hey, please make sure, well, check whether this user operation has been signed by the session key or not. So, and if it is, we let the user execute, right? So what we do here is instead of making the owner the only like person or account that can interact with the Openfort account for that specific period with for that specific whitelist of addresses, the user will be able to submit a lot of different user operations signed by the session key without pop-ups, right? So this is all handled by this is valid session key function. And the cool part is that session keys are not like, they don't have access to any function. Remember that when we talked about EOAs, we said you could do anything as long as you have the private key, or you cannot do anything if you lost the private key. With session keys, it's different. With session keys, you can only execute, call execute, or execute batch. So with a session key, you can only execute functions, like make the Openfort account execute functions. But for example, with a session key, you cannot transfer ownership, for example. So let's say you created a session key and you're playing with it. So maybe if that session key is leaked, a malicious user would say, hey, now that I have 1 day with full access to this Openfort account, let's change the owner. No, you cannot do that. Why is that? Because session key works only for 1 day to interact with a specific contract and only using the execute and execute batch functions. So this is more like a protection. So I think like now I may be answering like your previous question, saying that okay, how does the player interact with the account? So typically, while playing, they will use session keys. So instead of having a lot of pop-ups of like signing and not signing, they will only have one pop-up to register one session key at the beginning of the game, and then that's it. They will like freely interact with the game without pop-ups or anything. Yeah,
Question.
yeah, sure.
So session key, what's a normal duration? Is it for, okay, I will play this game for 3 years, the session key is like 3 years long, or what's a typical
That
duration?
that highly depends on the game. We have seen games saying that okay, our typical I don't know games or typical fight or whatever, they last for 20 minutes. So what we'll do is register one session key that lasts 30 minutes only, because
Mm.
that's the time we need like the user to they will be like without any kind of disruption. They will be all the yeah, they'll be like playing with the game without any interruption. And then if they want to do another fight or whatever, they will need to register again. But then we have games saying, okay, I don't know, I have this policy that I want to register a session key for 1 day or 2 days. They're allowed to do that, but they must know that the longer the period, the longer the risks, right? Uh, Even though that the user can always revoke session keys. We have like a revoke session key. So this is called by the owner. So let's say that the user is afraid of like, I don't know, like let's say that they lost a device, like a laptop that had a session key registered that would last for a week, for example. They can always, if it's custodial, ask Openfort to revoke the session key, or if it was self-custodial, they could use their MetaMask on another account, on another device, and say, hey, let's revoke this session key because I don't trust this game anymore, or I don't trust this device anymore, right? Um, so now that's like, well, we have like different contracts for well, different kind of implementations for the different kinds of accounts. But if you want, we could maybe leverage our API to use an upgradable account, which is the mostly like right now, most of our clients, they use upgradable accounts. So typically, because we are API first, we use an API. So if you like, well, if you have any like further question, just feel free to ask. If not, I'll just do like a quick demo.
Yeah, go ahead, go ahead.
Sure. Okay. So well, as I said, like we are API first, any interaction with Openfort can be done using our API. But let me maybe first show you also how to create an account. So for example, let's log out. So if you want to give it a try, you'd go to dashboard.openfort.xyz and register, right? What I do is I have like um, a Google account, which give me access to my dashboard. What I did before starting this call, I created a bytecode YouTube project in case we have a demo effect. Because I have time. I think we have time. I think we could do it from scratch. And if we have any problems, we can go back to this project, which I created today. But let me go through the whole process of creating a project and then interacting with an account. So let's say we want to create a project, which can be called bytecode YouTube 2. Once we create a project, we don't have any player, we don't have any asset in the game, like we don't have any policy. So who would typically create a project on Openfort? Because our clients are game developers, so game studios. A game studio would create an account on their dashboard, and they would create a project for one of their games. Once they have this, they will not have any player or they will have any asset. An asset here would be like an NFT, for example, like a shield a sword or whatever. A policy is something that it's a gas policy. Like a gas policy is something telling the paymaster, hey, please sponsor these transactions to this kind of transaction to our players because we want to pay them anytime they mint a reward or a shield or whatever. We want to pay for that. the beginning, right? For easy involvement. So here, if you notice, we don't have anything here created yet. So we need an API key. This is in test mode. So we need an API key, and let's copy this, and we need to use it with our API. So we can go to an environment, our demo, and make sure that the environment variables are correctly stored. Once we have this and it's active, we can go to our collections and say, hey, how many players do we have? And you'll see that we don't have any player in that project yet. So what we can do is what can create a player. This is all still Web 2. This is still, like, if you create this is still all Web 2. And here we have like a player ID. So game studios can now link their players in their games with this specific ID and say, okay, I want to see, for example, how many accounts this player has. And we'll see that because it's a new player, they don't have any account yet, like any blockchain account yet, any Openfort account yet. So if we go to players, we'll see that this new YouTube player is now active and it has 0 blockchain accounts, 0 Openfort accounts, right? So in order to have an account and mint some NFTs or some in-game assets, what we could do, they could go to asset contracts and create a new one. So the game studio could go and say, hey, I want to create an NFT in-game, which will be in Fuji. Actually, this simple NFT is the one that we use for testing. So this simple NFT is representing, I don't know, like a shield on the game. So we copy the NFT address and say it's on Fuji and paste it here. If it's not verified, we would need to paste the API here, but because this one is verified, we don't need. We will get the API from the Explorer, and now we have a contract created. So an in-game asset, right? Because the API was verified, we have all the different functions that we can call. So either the write functions or the read functions, right? So we copy this contract identifier. Well, we have this contract here. We'll use it later. So we also have to create a gas policy. If the user, the Openfort player, this player, has one account that has funds, they don't really need a policy. But because we need to create an account that doesn't have any funds yet, we better create a gas policy. What is a gas policy? Well, we create it here and say, this is the simple NFT policy that will work on Fuji, let me say, on Fuji, and we will pay gas for user. We can also charge the gas by custom tokens. For example, we could say, hey, I want to use the paymaster, but not to sponsor all transactions, but to get the payment back in USDC, for example. We could do that. But for now, the mostly used case right now is in order to have more players in our games. At the beginning they say, hey, I want to pay gas for the users, but only for minting, right? So we have we are sponsoring all the minting of the shields and swords or whatever, and rewards and everything. But then if they want to, for example, transfer them or, I don't know, burn them or wherever, they will need to pay themselves. Like they will need to pay for that functions. You could have that as well. But let's for this sake of simplicity, let's say that I want to pay gas for all users for all functions, and then not only contract functions, but also account functions. So let's say I also want to sponsor the transfer ownership. So once the users say, hey, so far I've been playing with this account, I don't have the custody, but I want it. I want to gain ownership. I want to call the transfer function. They could do that, but if they don't have funds, we can also sponsor them, like the transfer of the ownership. And we save the policy. So now, if you look at the API, for example, we can check that. For example, if we go to get policies, we'll see. Well, let's not filter anything. We'll see that we have one policy that is the one that we have just created. It's created, yes. That's the yeah, now here. So as you'll notice here, the identifier is this. So this is identifying that the simple NFT policy that we have created on Fuji that is still valid and will pay for user, right? So what we do is we copy this policy and we want to do a transaction, which is the cool part, right? The final part. We say, okay, we have accounts, we have contracts, we have players, we have these policies, we have session keys, but okay, I want to do a transaction. I want to actually mint an NFT and say, hey, I gained this reward. So what we do is if we want to Openfort or the game developer to sponsor for the transaction, for the user up to take place, we will use a policy. We will also need to change the player, which we have here. Let me see. Player, I think it was this one. Player, we can take it also from the website, which is cooler. Contract, we want this contract. So what we would be doing here is that, okay, I have the intent to do like this transaction. This player on Fuji wants to do like optimistically, wants to interact with this contract, which is a shield or represents like anything, and wants to mint it to a certain address and it needs to be sponsored, right? So once we send this, what we'll do is, because the user doesn't have an account yet, this will take a little bit more time, because what we're doing here is we're sending a user operation signed by Openfort saying, okay, please create this account for this user that we will sponsor using the paymaster, right? So this is the sender is the new account that has been created. So notice that it starts with 63DE. And if we go to players, we'll notice that YouTube player has now one account. If we view this account, we'll notice that it has a new account on Fuji that starts with 63D and has minted one asset. If we visit
Eloi,
it on Fuji, yeah.
could you go into more detail of what just happened exactly?
Sure.
What does it mean to create an account exactly?
Okay. If we go to the source code, we have now created the default one, which is an upgradable Openfort account, and we have reviewed the accounts, right? So your question is because maybe I forgot to explain about factories. Factories is another element that it's like part of the standard of year 3437. So you just don't have accounts. You also need a contract that creates accounts, right? So for that, we have, for example, a factory that creates upgradable Openfort accounts. We also have a factory that creates static accounts. We also have a factory that creates recoverable accounts. So a factory is just a contract that is in charge of creating new accounts. So
Okay.
what happened is when we mint an NFT, we are actually calling the create account with nonce, which is saying, hey, because this is custody, we set the admin as Openfort at the beginning, but you can change that. You could create an account and say, hey, this user is a Web3 native. This guy knows what he's doing, and he wants to be the admin since the beginning, from scratch. Like we support that. We say, hey, we have in the API, if you add like and I think it was you have all the documentation in our website, but I think it was owner address. So if they here put their address here, instead of just creating an account that the admin is Openfort, they would have an Openfort account that is owned by them, and then they have a nonce, right? To create different accounts, and then from that, what we'll do is we would initialize the Openfort account that we create using the admin as the initial value, as well as the entry point contract, which is the entry point that the account will follow, will accept, right? So if we look at in the Explorer, we'll see that this account was not here before. We see that Openfort is now still the custodian because we didn't provide any new account, like any new address. So if we go to Fuji and say, hey, what happened here? We have a contract, which is an upgradable proxy. As we said, we can upgrade these contracts. So because it's a proxy, we can say check that it's a proxy, and we can read it and say, hey, what had just happened? Like let me see, for example, in the internal transactions, right? We had like 3 minutes ago, we had a contract creation, which was the bundler. This is the address of the bundler that interacted with the entry point address. If we check this, this is the entry point. So we have a bundler that interacted with the entry point and said, hey, in entry point, I want to interact with the factory and create an account creator. So this is the address of the factory, upgradable Openfort factory that has just created an account, which is 63D, as we noticed on our dashboard. So the cool part here is that you don't really need to create a blockchain account when you have a player on your game. You can have a player, and before we only had 0 accounts. But once they interact with a certain asset, you can mint it. And if you mint it using an account, a player that doesn't have any blockchain account, it will be created at the same time. Like it will
Okay.
be in once, like notice that the transaction hash is the same. Transaction hash is all the same. So what we do is in one transaction, we create the account and we mint the token. So now this Openfort account has, well, it should have the, well, that's weird. So the launch is one, the owner is an Openfort owner account. And what is weird is that I think it's not indexed yet, but we have
Shouldn't it be 721, not an ERC20? Is that why?
yeah, that's true. I think it's an NFT. Let me check. You're right. So what we could do is just check the balance of our player. Sure, but that's weird. Go to the events. We'll see that. Oh yeah, sorry. Yeah. Here notice that what we did in our API, sorry, is that minting, but not to ourselves, but to another player. Here I said, but that's the way, like that's how the function I called. What we could do is say, hey, I want to copy this and mint it to myself. Send. I'm sorry, and then remove the owner because we don't have an owner. Now what we are doing is we are minting ourselves a token, right? If you still don't have the address, you can put the player address. Like you could use, for example, like we use counterfactual addresses, so we know the address of a player before deploying it. So you could use this address before deploying it if you want. So we see that the first minting succeeded. The second one is still processing. If we refresh, we'll see, it's taking a bit. You see the transaction intent, it is still successful, right? So we can now go to Fuji, see the transaction hash, and see that now we minted a simple NFT from 0 to our address. So now the Openfort upgradable proxy has a simple NFT, and the nonce has been updated to 2. Remember that the nonce is being handled by the entry point. Yeah, and I think that's pretty much it. Yeah, do you have any
Nice.
question about all this?
No, great demo. I really like how
Thanks.
frictionless. Yes, I really like how frictionless it is. You know
Thanks.
that you can have an account, okay, and when you do the first transaction, you actually deploy a proxy
Exactly.
that's really cool.
Yeah, exactly. Our clients, they are loving this because they have a lot of users that they don't end up minting anything. So instead of just deploying a lot of accounts that they will never be used, what they can do is they can start, like they can get a lot of users, and then once they mint NFTs or assets, they are then interested in gaining ownership. So they transfer ownership and everything. So everything takes place when you need it. And then for like regarding session keys, you also have a sample that if you want, you can so give it a try. But oops, no, that's not. So as I said, like before, we can go to samples and for example, try our that session keys. You can also try this pop-up-less minting of tokens using Openfort if you want to as well.
Nice. Really cool stuff.
Thanks.
Okay, Eloi, perfect timing. We are exactly 1 hour and 7 seconds in.
Perfect.
So yeah, I think it would be great time to stop here.
Cool.
But yeah, this was super interesting. I learned a ton about account abstraction.
Good to know. Thanks.
Yeah, I haven't looked at account abstraction for a while, so this was super interesting. So yeah, thanks again. Thanks for taking the time.
Thank you.
Eloi, where can people find you? Is it Twitter?
Yep. You can find me on Twitter. I'll send you the link if you want, and you can. I will also send you the Openfort Twitter as well, on our website. So yeah, feel free to reach out to us or to me on Twitter, on our Discord server. Like any feedback is really appreciated.
Awesome. Then I'm gonna link Eloy's Twitter, Openfort Twitter, the repository, the
Awesome.
links to all the account abstraction resources in the description below. Eloi, thanks again for taking the time, man.
Cool.
And guys, see you on the next one.
Like,
Bye bye.
cheers. Bye
Bye.
bye. Thanks.